Okay, so we're given a curve C with the implicit equation xy equals y squared plus x squared is equal to 5. For part A, we want to find the equation of the tangent to C at the point P, 1 minus 3. Part B, we want the equation of the normal to C at P. And part C, we're told that the normal intersects C again at the point A. And we want to find the coordinates of A. So I'm going to break this into its different parts and work through it a bit at a time. So part A wants the equation of the tangent. Now if it says to do with the equation of the tangent, you should be thinking gradients, therefore dy by dx. So we need to differentiate our expression. We're told it's an implicit expression, so we have to use implicit differentiation, and we've got a product here, xy, so we need to use the product rule as well. So we can leave x on its own, we can differentiate y to get dy by dx, plus leave y on its own, the differential of x with respect to x is 1, so we can leave that. Plus move into the y squared, the differential of y squared, 2y times dy by dx is equal to, and the differential of x squared, 2x, the differential of the constant 5 just goes to 0, so that's our expression. Well, we're given the point P is 1 minus 3, so we can now substitute in the x and y values. So x equals 1, y equals minus 3. So dy by dx minus 3 minus 6 dy by dx is equal to 2 when we simplify and substitute in. So therefore minus 5 dy by dx is equal to 5, and dy by dx therefore is equal to minus 1. So from that we have just found our gradient of the tangent is equal to minus 1. We want an equation of the tangent though, and a tangent is an example of a straight line, and that is in the form either y equals mx plus c or y minus y1 equals mx minus x1. Take your pick. I personally prefer y equals mx plus c. We have our m is minus 1. We have our coordinates 1 minus 3. And all you need to do is substitute in. Minus 3 is equal to minus 1 times 1 plus c. Minus 1 times 1 is minus 1, moves over, becomes a plus. So therefore c is equal to minus 2. So our equation of the tangent is y is equal to minus x minus 2. So we found our equation of the tangent. Now we can use part of our result here to find the equation of the normal. Now we know that the gradient of the tangent, as we found out in the last part, is minus 1. So we can use that to find the gradient of the normal, which is minus 1 over the gradient of the tangent, and minus 1 over minus 1 is 1. Okay, it's about as nice as it gets. Well, it's still at the point P, and it's a tangent, so we're still in the form y equals mx plus c. So you've got the gradient is 1, p is at 1 minus 3, and all we need to do is substitute in. Minus 3 is equal to 1 times 1 plus c. c is equal to minus 4. So therefore our equation of the normal is y is equal to 1 for our m, so we can just put x minus 4. So that's our equation of the normal. Now part C, we're going to use that because it tells us the normal intersects C again at A. Find the coordinates of A. So there's a little bit more work for this part, and it's reliant on us getting a solution at part B. Now, if it's a point of intersection, we've got y equals x minus 4, and we have our original curve xy plus y squared is equal to x squared plus 5. And all we're going to do every time we've got a y in this expression is replace it with x minus 4 like you normally would do for a point of intersection. So you got x times x minus 4 plus x minus 4 squared is equal to x squared plus 5. We can expand the brackets. X squared minus 4x plus x squared minus 8x plus 16 is equal to x squared plus 5. X squared plus x squared, 2x squared, take away the 1. So we go 1x squared minus 4x minus 8x is minus 12x plus 16 minus the 5 plus 11 is equal to 0. At this point we've got a quadratic, so we can factorise it and say that we have x minus 11 x minus 1 is equal to 0. Just check it. Plus 11 on the multiplication, minus 11 minus 1 minus 12x, that's fine. So x is equal to 11, x is equal to 1. So we have our x solutions. We look at those and we're going to say, well, we should be expecting one of them. And indeed, we've got x equals 1, which matches up with our point P. And as we were using that to find the equation of the normal, that's a very good sign. So we're going to need to use the x equals 11, but we want the coordinates of A. So we also need the y coordinate. So at x equals 11, therefore y, which is equal to x minus 4, is 11 minus 4, which is equal to 7. So therefore our coordinates of A are 11, 7. And that is how we find the equation of the tangent to C at P, the equation of the normal, and then when the normal where the normal intersects the curve again at the point A.